You good? Okay. Yeah, cool. So whenever it comes to testing, I always think about Kenzie Dots. I believe some of you already know him. He has this famous course called Testing JavaScript, where he teaches a lot of stuff about testing your JavaScript applications. And he came up with this image that I'm showing here, and it's the testing trophy. And it basically shows the 4 types of tests that you should have in your application, and where each type of test belongs, and what tools or what you should focus on testing for each of these types of testing. So it's shaped like a trophy, and at the bottom of the trophy is static testing. And the purpose of this type of testing is to just catch typos or errors as you write your code. So if you use TypeScript, for example, you already do static testing because TypeScript helps you a lot to catch these errors before you commit your code. Tools like ESLint, which is a linter, tools like Prettier, which is a code formatter, fall under this category as well. Tools like Husky. Husky is Git hooks. So if anytime you run Git commit, Husky allows you to hook into that Git commit event and do something. And you can use libraries like lint staged to run your ESLint whenever a commit is made. So basically, the focus at this level of testing is to make sure that you don't ship code that is broken. Yeah, so today we are not going to do any static testing, though my examples are in TypeScript, so that's also yeah, part of static testing. Then the next level in the trophy is a unit test, and here you're basically verifying that individual parts of your application. So if it's a React code base, in this case, individual components, or your helper files, helper functions, they work well in isolation. So you can pass props into a component, and that component should render the thing that you expect it to render. Then we have the next level is integration testing, and this is basically unit testing, but when a unit depends on another unit and you have to test them together, then that is what is referred to as integration. Just verifying that these different parts of your application can work together in harmony. And then last at the top of the trophy is M2n testing, and here is where you run a full test of your application. So it's normally you launch a browser, and in that browser, the testing tool can perform some actions like click, fill forms, and submit stuff to a server, which is normally in this case a real server, and verify some things. So end-to-end testing is at the very top of the testing trophy. So today we're going to talk about unit testing, and yeah, probably touch on some integration tests as well. So since I want to show testing, I didn't make anything to test. I'll just use the default app that you get when you bootstrap an application. So for the longest time, I've been using Create React app, but for today, I'm going to use another build tool called Vite, and yeah, Vite is created by Evan Yu, the creator of Vue.js, and it's basically does the same thing like what Create React app does. So what I did is you run this npm init Vite at latest, and this is how the UI looks like. When you run this command, it just asks you 3 questions. One, to name your project and select which framework you're using. So you can bootstrap a vanilla JS application, a Vue, React, Lit, and Svelte. So I chose React. Then it allows you to use to choose a variant. So I chose Reactjs to have the TypeScript version of this. So the moment you press this, it creates a bunch of files like we have here in your project. And all you have to do is npm install, and then you can run the app with npm run dev. So if I run this npm run dev, it serves an app on localhost 3000, and it's just the default app you get when you run create React app. Just a page with a button which uses state. When you click on it, yeah, the counter increases. So we shall be testing this app and see how to do testing. So maybe it's interesting to see a little bit the structure of the code. So a Vite app has a Vite config TS. This is where you configure your stuff. If you use create React app, they use Webpack for configuration, but Vite doesn't use Webpack. And then because it's a TypeScript project, we have a TS config JSON file. And then our package JSON has 3 scripts right now: dev for running the dev server, which we're using now. And you can build your app for production, and preview allows you to serve the production version of your app that you've built. And then, yeah, we have an index file, which has a div ID root where our React application will be mounted. And we load the main application script from the source folder. So in the source folder, we have main TS, which renders our app on that root div. And this is some TypeScript inference stuff, a CSS file for the application, and the app file. So I moved some files around because I have a second example. So I made a folder called screens, and the default stuff that came with Vite, I put it in the home folder. So it's a React application uses state count here, and we have a button. And on clicking the button, it sets the count to the previous count, incrementing it by 1. And what I'm doing is in my main app, I have this package called query string, which allows me to pass params on my query. So I can say like screen is home, yeah, to get this. And I can also load the second example by passing a different query param. So if this the value of the query param is home, I load the home component, and if it's fetch, I will load the second example. And if I don't have anything, I load the home script. Cool. So this is our app. Let's see how to test it. So to test the app, I will also use a package, another package. It's a test runner or a test framework, and it's called vtest. So from the same family as Vite, one of the Vite core team members made vtest, which is a unit testing framework. It's similar to Jest, if you've used Jest before. And yeah, we set it up. So to install Vite, we'll install it as a dev dependency. So I'll kill my server and run npm install vtest. And then once that is done, we need to add a test script in our package JSON that will allow us to run our tests. So once we install vtest, we have this binary, and we can use the run command to run our tests. So vtest run will run our tests. So the install is done, and I will add a test script here. Test run. Okay, so with that, now we have a test script, and I can run npm run test. Of course, I don't have any tests in my application, so I get that no tests files found. The good thing about vtest is that it's zero config, so you can already start writing tests without configuring a lot of stuff in the beginning. So it searches for test files across the project, files ending with .test.ts or tsx. So I will just create a new file in my home folder, and I'll call it home.test.ts. And this is our test file. So the testing framework gives you some functions that you can use to run tests, and we'll see some of them right now. So I will import test and expect from vtest. So the test function allows us to create a test and receives 3 arguments. We'll use 2. The first one is the name of your test. You name it a name that describes what your test is doing. And the second one is the function body that contains the logic for the test. So we'll just write a dummy test that it works. And I use an arrow function to make my test. So inside the test body, we make assertions. You can make assertions like what our test is doing. So we have this expect function, which allows us to check that a certain value matches a certain condition. So for example, I could say expect if I do some arithmetic, 2 plus 3, and then I can say to be, then put the answer there. If I save this file right now and I can run npm run test again, there's a shortcut to run the test script. You can also just say npm t to run the same test script, and we can see here that our test is passing. So it found one test in this file. It has run it, and the test is passing. If I had a wrong answer in there, and I run this again, what happens is now my test is failing because the result of evaluating 2 plus 3 was not 55. So it's telling me it expected the answer to be 55, but it received 5, and this is why the test is failing. So this is how tests work normally. If you noticed, I have to run the test script again each time I change something. So for a better developer experience, we have the watch mode, which runs your tests and watches for changes in your file. And if something changes, then the tests are run again. So I will add a test watch script in my package.json. So instead of running vtest run, we run vtest watch. And now I can run npm run test watch. So now my test runs exactly the same way it did, but it doesn't kill the terminal after it finishes. So if I go and fix my test right and save the file, the test will be rerun again, and yeah, I'll get to see the output. So we've seen the expect function, which basically checks that a certain value meets a certain condition. And to be able to make this kind of assertions, we have what we call matchers. So the matchers that vtest uses are just the jest matchers. So they come directly from jest, the other testing framework. So in their documentation, they list all the matches that are available in jest. We've used one to be, and we have a lot of matches like to be null, to be undefined, to be falsy, to be greater than. Let's look at some example matches. So I have some matches that I prepared here. So I have a function at the bottom here called meaning of life, and it returns the meaning of life, which is 42. So if I call the function meaning of life, I expect meaning of life to be 42. So to be uses object.is in JavaScript, which is equal to the triple equal to do equality checks, and works really nice if you have primitive values. I can also say expect meaning of life to be defined, which means it's a value, it's not null or undefined. So 42 is a value that is not null. If I say expect 0 to be falsy, this will pass because 0, if you convert it to a Boolean, is false. Expect meaning of life to be greater than 10. So you can make assertions like if a number is bigger than another number, or to be less than 50. Or you can do assertions like expect 30 plus 30 to equal. And then just has matches where if you don't know the exact value of what you want to match against, you can say expect dot anything, and this will match anything, any value that is not null or undefined. So this will be 60, which is not null or undefined. So this test will pass. If you have an array, for example, you can say expect the array to have a length of 3, so it does the length of the array. Or you can say expect this big array to equal, and then you can do a matcher like expect array containing another array. So I'm expecting that the first array contains all the elements that are in the array at the top. If you have objects, you can make assertions like expect the object to have a property foo, and the value of the property should be bar, stuff like that. You can say expect this other bigger object to equal, and then you make an assertion with expect object containing another object. So if you want to check if an object exists in another object, you can also compare objects. So if I have an object can1, which has flavor and ounces, and can2, I can say expect can1 to equal can2. So this does a deep equality check. It compares all the properties, that all the properties exist. So it checks that we have flavor in both objects and ounces in both objects. But if you use to be, so if I say expect can1 not to be, this is negating the assertion. Not to be can2, this will pass also. All the assertions I have here will pass. And this passes because it does shallow equality. It compares the references. And of course, these two objects are not the same. They are two different objects. So they are not the same. So to be the same will be false. And if you say not to be the same, that becomes true. Yeah, so if you want to negate an assertion, you can use the not keyword. So this is just examples of some matches that we get from Jest. So let's dive deep to specifically testing React applications. So Kenzie Dots also made another library called React Testing Library. Before this library, we used to use a library called Enzyme, if you've ever heard about it. So basically, React Testing Library is a library that allows you to test DOM nodes, and it provides some useful functions that can allow you to make assertions against React components specifically. So React Testing Library is just one part of the testing library family of tools. And it's just tools to test a lot of things. So you can test different frameworks like the DOM directly if you're writing a vanilla application, React applications, Reason, React Native, Vue, Preact, Svelte, Cypress. A lot of libraries exist under this umbrella of testing library. And today we're going to see about this React testing library. So to install it, install as a dev dependency testing library /React. So I'll come to my application and kill my tests and install this package. So once that is done, we can write our first React test. So I want to test the home component. This page here that we see. Oh, I closed the app. Let me just run the app again. npm run dev. Yeah, so we want to test this application here that it works fine. And to be able to test React applications, we will be writing JSX. So we have to first rename this file from a TS file to a TSX file. And then I will just get rid of this test and make a new test. So I will just test that this home component renders correctly. Okay, so we want to write our test now. So the first thing is, of course, to import the component that we want to test. So we import home from home. Now that we have this component, we need to render it to the DOM, the DOM for testing, the same way React renders applications. So React testing libraries provides a function called render, which allows you to render components to the DOM. So I'll import render from testing library React. And with this render function, I can say render the home component. So what React testing library will do, it will do something similar to what the browser is doing for us here by rendering the application on the browser to create the DOM elements. And once the app is rendered, we can access it. So like I can consider this app like a screen. So React testing library has another function called screen, which provides some nice methods that allow you to do something on the rendered app. So just as a beginning, I can do a screen.debug to see the DOM structure that is generated once this component is rendered to the DOM. So I'll save this and we'll come back here and run our test in watch mode. Okay, and then we run into an error. Reference error DOM is not defined. So React renders our application in a DOM, but our testing environment does not have a DOM. Like we don't have a browser environment to render this app. And that's why we get this error. So we need to do our first configuration to make an environment that React can actually render the application into. So vtest provides 3 environments, and by default, it uses the node environment. So this test is running in the node environment, and in the node environment, we don't have any DOM. So we have to switch it to run in a DOM environment to be able to make assertions against this rendered application. So to make configuration for vtest, we'll use the vit-config ts file. And what I need to do is come here and add a new key test. And I will just add this line at the top so that TypeScript can provide for me some auto-completion for what is possible to configure here. So now I can see all the options that I can configure, and what we want to configure now is the environment. And I see I have 3, chose 2, 3. I have Happy DOM, JS DOM, and Node. So JS DOM is what we're going to use. And what JS DOM does basically is it creates a fake DOM environment for us to use in our tests. So our application will find a DOM node where it can attach our React component. So if I save this, and if you change configuration, you have to kill the app and restart the tests and restart them again. And yeah, we get this JS DOM is not installed. So by default, to make vtest light, they don't ship a lot of packages with it. So if you want something, you opt into it. And in this case, we need JS DOM. So they ask if you want to install JS DOM. I'll say yes. And this goes to npm, picks up a package called JS DOM and installed C as a dev dependency and adds it to our package JSON here. So now I start the tests again. And we have a test passing. And here we can see what the debug script printed to our console. So we have the DOM structure for our component. We have a body tag, and it has a div with a class of home and a header with an image, and it says hello vit. It has a button which right now says count is 0 and renders some 2 links at the bottom. So this is exactly the same app that we have here on the page. And now we can be able to make assertions against this app. So first step was to render our app, and then now we can make assertions on the app. So to make it simpler to make assertions, there's a really nice tool that we can use. And it's called the testing playground. It's basically a website which you give it your DOM structure, like what you got from the debug, and then it gives you some nice selectors that you can use to query things from the DOM. So to be able to get this playground already with our DOM in it, we can use the debug log testing playground URL function here. And what this will do is basically when we run our test now, it will print out a link on our terminal. And if I click on this link, it will open the testing playground. So this is the testing playground over here, and puts our DOM in the playground already for us. So with our DOM, we can see how it renders. Of course, doesn't find the images, and clicking on stuff doesn't work because there's no state, React state here, but you can see the different elements in the DOM. And when I hover on the element, I can see how to select the element. So how I can get access to this element for my tests. So basically, what we want here is to find a way to query our selectors. And the recommendation, there's a recommended priority of how you should be able to access selectors. And the rule of thumb is you should think the way your user uses your application. So if a user comes to the application here, they will see there's an image spinning here. There's some text, and the text is hello vit plus React. There's a button, and they can click on the button, and there's some more text, and there are 2 links. So we want to select these elements the same way the user would select them. And to be able to do this, we can use the role of the element that comes with the HTML in the DOM. So for example, if I highlight the first selector, we can see at the bottom here that it has a role of image, img. So this is an image. If I select the second one, it has a role of button. So I can select it the same way a user will see an image, will see a button, and I can use the role to select an element. And the last one is a link. So stuff like that. Sometimes there is no role. So for example, if I select this text, it doesn't have a role. So if something doesn't have a role, you can use the label text. Let me show an example of the label text. If I open the default playground, they have a form here. So if I have a form element on the page here, I can see that it has a label text associated to it. So email address is the label text. So a user might say, I want to fill the password field. And they are saying that because they see that the label on the field is password. So you can select using the label. If the label is not there, you can use a placeholder. So for example, the password box as a placeholder of password. or you can select something by the text that you see on the screen, or you can select something by the value that is displayed in an input, for example. So if my input had a value of hello, and I select it, I can get a display. The display value of my input is hello. So React testing library provides this get by role, get by label text, get by placeholder text, get by text, and get by display value that you can use to select elements from your DOM. So if these things are not available, you can go to the second level and select things by their semantic value. So normally these are values that screen readers will see, but your users will not see. For example, if an image has an alt text on it, so we have an image here, this image, and it has an alt text of logo, and we can select by the alt text, an image with an alt text of logo. But the user will normally not see this, so that's why it's not recommended to use these semantic queries. Or you can select something by the title. So if an element has a title attribute like new, it has a title, you can see it here. And finally, if you can't get an element by any of the other two methods, we have an escape hatch called a test ID, and I will show an example of using a test ID to do this. So let's write our first assertions against the DOM. So what I'll do is I want to confirm in my test that the image is loading on my page. So what I do is on the testing playground, I'll click on the image. I'll get the selector here, and I'll copy it to my clipboard, and then I'll go to my page. We no longer need this. And the same way we just wrote tests before, I'll say expect. And what I'm expecting is this element. So screen.get by role image. I'll just put this on one line. Like this, and then now I can make assertions against this element. So for example, I can say I want to make sure it's in the page. So I can say it should be defined. So it should not be undefined, or it should not be null. So it should be there in the page. So I say expect this element to be defined, and this makes sure that this element is in the page. I can also make another assertion. I can just copy this and say, so we want to make a second assertion that this element has it's our component home. We want to confirm that this element has an attribute, the alt attribute, and the value of this attribute is the word logo. So I can come and say to have attribute and then I put here which attributes I want to wait, I don't have this yet. So I'll say get attributes. I want to get this is just me getting the attribute of this element using JavaScript, and the attribute we want to get is attribute. The attribute you want to get is the alt attribute, and I want to it to be equal to logo. So I have GitHub Copilot is messing my code. So I have long brackets here. I say expect. Okay, I need to close this here and not here. Okay, so expect this element get its attribute and its attribute alt to be logo. So let's have a look at our test again. So if I just save this file, my test should rerun again, and they pass. And we can check that we can fail our tests. You should always make sure that your tests can fail to be able to know that they're actually testing what you think you're testing. So now if I say that my attribute should be logo X and it's not, I get the test to fail. So it means my test is actually testing the correct thing. So now I'm running a unit test to check that my page loads my image and my image has the correct alt text, which is, yeah, that is the main thing about testing. And you can be sure that going forward, as long as these tests run, your image will always be on the page and your image will always have the correct alt on it, alt tag on it. But as you can see, like making assertions against the DOM using the just matchers, like to be defined, to equal, is a little verbose, and you end up writing a lot of code. But there's a library out there that has made some custom matchers, which you can use to extend the just matchers that make it easy to test the DOM elements. So we have a package called just DOM, which adds some more matchers to the default matchers that come from jest. And if I can just show some of the matchers that we have here. So we have things like to be disabled, to be enabled, to be an empty DOM element, to be required if it's an input, to have attribute. So instead of using get attribute and then matching on that, you can just say to have attribute, to have class, to have style, to have value. So these matches are really important if you are testing React applications. So we shall install this library. I will kill my tests, install this. And now once this is installed, we have to tell Jest to use this additional library matches. So to do that, we have to do some little setup in our app. So what I'll do is I'll make a new file in a new folder. The folder will be called tests, and the file will be called setup. Yes. And in this file, I will just import the just DOM. This will import all the new matches from just DOM and then extend them on the matches that come from jest, so we can have access to them in our tests. Now that we've added this setup, we need to tell vtest to use the new setup. So we need to go to the config and change two things. First, we need to say globals true. So what this does is it makes all these exports from vtest to be global variables because just DOM needs them to be accessible. And this allows just DOM to have access to them. And then we'll also say that the setup files, we are setting, we want to set up the test environment before we start running our tests. And we tell vtest that it can find the setup files in our new tests setup ts file. So every time it starts up, it goes to this file, loads whatever is in there, and then starts running our tests. So if I kill this and run the tests again, my tests still run, but now we have some new matches that we can use. So instead of saying to be defined, we can say to be in the document, So to be in the document just asserts that this element has been mounted to the DOM and it's visible. And instead of here saying get attribute first and then to be equal to something, we can just use the matcher to have attribute. And our attribute is the alt tag, and here is the value of our attribute. Our tests still pass. So if someone in future comes and changes this application for whatever reason and changes the alt text of our image, our test will fail, and we will know that something is broken in our application. And also, because of this matches from a JSTOM, we have some nice error messages. So it says unable to find an accessible element with the role of image with the name of logo. So we are looking for an image that has a name of logo, but the React testing library was not able to find anything. It tells you here are all the elements we found that have accessible roles. There's the header, this image that doesn't have an alt of logo, instead does something else. There's the button and there's the two links, and here is the DOM that we currently have. And if you read this error message, it's easier to understand that, oh, I am missing my element, but I can get it, and here it is. So this makes it easy to know whenever an app breaks due to a feature refactor, and that's the value of having tests in your application. So let's go through some a little bit more assertions here. I'll just paste this and go through them. Okay, so we added some more assertions here, and one of them is expect the image to have attribute source, and then because the source of the image is a path to some place, so React will go pick this file, bundle it, and create the file in a public folder, and then give us the path that will go into the source. We just want to make an assertion that the file called logo.svg is the correct file that was put in the image, and we can say expect string containing logo.svg, so that the final image is a string that is a path, but in that path we don't care where it comes from, but it should contain our image in it. We can also say expect the image to have a class of home logo, so you can test that the class name is there. If this is important for something else other than styling, it will make sense to put it in the test. Then we can test that the text hello vit plus React is in the DOM. So here we're using regex to find the correct words without caring about the capitalization of the word, and this matches really nicely. Remember, these assertions, these matches, I'm getting them from the testing playground. So this is the get by text hello vit. We'll select this element. Yeah, so we are here, and then expect that the text edit something to exist. So I put an asterisk here to say I don't care what is here, but I just want to check that edit and save text exists in the DOM. So that's the assertion there. And then we have for the links, we have get by role link with the name of Learn React. It should have an attribute that goes to the React website. And the other one that links to VitDocs has the href, that href. So this is how you would write your tests. And the philosophy you follow when you write tests, we have this thing called arrange, act, assert that is used whenever you write tests. And I will just explain it briefly here. So we want to do a test that when the button is clicked, then the count is increased. So we know that in our application, if I click this button, then the count on the button increases. So what I do is I come to the playground and I figure out that this button, I can get it by role button with the name count is 0. And then in my second test, what I'll do is I will prepare the test environment, the test setup, and that is the arrange part. I arrange everything that I need in order to run this test. And in my case, it's simple enough as rendering this home component. So I'm setting up everything so that I can have the DOM necessary that I need to be able to run assertions against. And then act is the user will do some certain action. So here we're saying when the button is clicked. So the action is clicking the button, and then we can make assertions after clicking. So I've arranged my environment. Now I have the button in the DOM. So I can act on it by clicking on it. And to be able to do that, I need to import another function from React testing library. It's called fire event, and fire event basically allows you to fire DOM events on DOM elements. So I can say fire event dot and then the name of the event. So I'll fire a click event on this DOM element, and the element is the element with the role of button and with a name of count is 0. So I'm acting on the DOM that I've rendered up here, making sure that I get it to the state that I want to make assertions against. And once I finish arranging and acting, I do my assertions now. So the pattern is called arrange, act, assert. And now I can make assertion and say, expect screen.get by a role button. So now I'm expecting that there's a button in the document, and this button should have the text count is 1. So I have a count is 0. I click on it, and there should now be a button in the DOM that says count is 1. And as you can see now, if I save this file, we have 2 tests passing. And if I just do a mistake and say count is 5, that if I click on my button, the count should be 5, then my code will not, my test will not run. And I will know that there's something wrong with my test or my application. So now that we have seen the act, arrange, assert, I will just briefly come back to this item I talked about before, the test IDs. So sometimes you can't find a nice selector by using the things that the user can see. Or sometimes in cases like this, for example, where the selector that I'm using is actually the thing that is changing, it doesn't make too much sense to use this because if I click this 3 times, then the actual text in the button is what is changing. So maybe in cases like this, it's okay to use an escape hatch and add a data attribute on your element in the DOM so that you can capture the element by this data attribute. So a data attribute and that we use is test ID. So data hyphen test ID, and you can give it any name you want. So we'll go to our component, and in the JSX, we'll come to the button. We have a type. We want to click, and we can add a data test ID and save this. If I show this in the playground, so if the button in the playground had a data test ID, and I select it now, you can see down here that I have a data test ID of count button, and I can say screen.get by test ID count button instead of getting by the role or by these other queries. So example for this will be the same test that we have. If we can just modify it a little bit to use the data test ID, it will look something like this. So I render the home component, I arrange my setup, and then I capture the button by getting it by the test ID count button. And I can assign this to a variable because I need to use it multiple times. And then I'll fire an event. I click an event, I'll click on the button that I've gotten from the DOM. And then I can make assertions to say, expect this button to have a text content, count is 1. So the content, the text of the button is what is changing. And if I have a wrong value here, then this test will fail. So sometimes, it might make sense to use a data test ID to test your application. Sometimes, it's not. And most of the time, you should just focus on using the things that a user will see. A user will see a button that says count is 10. And if you get this button by the role and the text on it, it's a much better test than if you put a data test ID, which is something that a user does not see normally on your page. Okay, so cool. So now we have our 3 tests here. We are testing our components. There's a lot of additional stuff that you can do around testing. Things like coverage. You can set up your tests so that they tell you how much of your code base is actually tested and how much of it is not covered by tests. You can put this in a CI pipeline, for example, GitHub Actions, so that your tests run every time you push code to GitHub or you make a PR. And this just gives you confidence that if you come back to this code base 6 months later and you mess up with this stuff, let's say you remove the button without knowing, the test will fail and tell you that we expected a button to be on this page, but we can't find it. And this is really cool. It gives you a lot of confidence when you're refactoring your code. You're not afraid of breaking anything, because you're sure that when something breaks, your tests will report this to you. So I have a second example, but I think I will not go into it right now because I'm already seeing the time is gone. So I would suggest that we do a Q&A or discussion on this introduction that I've just done, and we can do another session and go through the other stuff, because if I start it now, it will take like an hour or so. The second example is basically a React application that makes network requests, and how you can be able to test this. So maybe you can just show the application. It's a basic application with a button. This is the official example that is on the React testing library documentation. I just adjusted it a little bit. And if I click on this button, I have an endpoint somewhere where if I call this endpoint, half of the time it returns a success and half of the time it returns an error. If I inspect this page and check the network tab, if I click this button, I make a request to an endpoint / greeting, and right now it has failed. It returns to me an error, and if I have an error, I have the text "oops, I failed to fetch," and the button is still active. And if I click the button again and I get a successful message, I get back a greeting from the server, and I can display it on the page, and the button is disabled. And the second example is basically showing how you can write tests that test this component. So this is more of the mix between unit test and integration test, where you're testing how all these things work together, and how to make sure that we can reliably test this application without making the network request to the server, because if the server fails, then our test will fail, and that is not what we want. So this will be, I will skip it for now. Or Rama, what do you think?
I don't know if he's still around or if he's dropped off, but I think we can have another session on this. It's really interesting. Personally, I'm interested in learning about that. So so we can plan maybe next week or some other day and have this. Yeah. He says we can have a part 2 on this.
Okay. Yeah. Okay, makes sense. So what I would say for now is that I open up if anyone has any questions about the stuff we've covered already. Or I'm just interested in knowing if you guys write tests, if you've written tests, if you've done any of this stuff before.
I can go first. So I haven't written tests, although it's on my to-do list, something that I want to do. I've actually wanted to start learning writing tests for React actually this year. So yeah, it's been an interesting session, and I've actually learned so much. I'm still going into it.
Cool. Yeah, that's nice. So Andrew says he's written tests using Enzyme and Jest, and it was premium TS. This is definitely friendlier. Yeah, I would agree with Enzyme being difficult to think about your tests. I also started writing tests when Enzyme was their tool to test React applications. The problem with Enzyme is it was allowing you to test a lot of internal stuff like state and props, and normally this gets really out of hand really quick. But yeah, React testing library makes you focus on testing how the user will use your application. And if you think of this, an application like this, then yeah, it's more straightforward figuring out which parts I need to test and which parts I don't need to test. And tools like vtest with their zero config allow you to get started really quick. So what I usually always do is every time I create a new project, I just add install the testing packages and add a test script. So it's easier every time I work on something small to add a test for it because the setup is already there. I think that really helps a lot.
Thank you so much. Yeah, another question.
Yeah, this is a question from Andrew again. Have you ever needed to write tests for state management like context or Redux? Yes. I have tested applications that use Redux and also tested applications that use React context. It is, yeah, like straightforward if you test how the user uses your application. So the user doesn't know that you have Redux in your app or doesn't know that you have React context in your app. So the only thing you need to do is whenever you render your application, you make sure that you wrap your, so in React testing library, we have this render function here where we are rendering our component. So with context and Redux, the only thing is that you need to have a provider that wraps your components and provides the necessary values that your component needs. So what you will just do is, so for example, if I have a context called theme context, for example, I will just wrap my element in a theme context, which I will import from the theme context in my application. And this will render my application with the theme context already set in the application. And I can make assertions on the UI just the same way a user will use my application without caring about what's happening in the application itself. Previously, there was this pattern where people used to test their reducers. Like you test the reducer by passing values into the reducer and picking stuff up. Oh, actually, so like in the second session, maybe I can just show a small glimpse of this. I'm using a use reducer hook, which is basically in the same category as having a context provider, for example. And in the tests, there's no time where I test this reducer directly. I just test the application, and by testing the application, my reducer will be called, and the UI will get into the proper state, and they can make assertions against that UI. So we yeah, like if we have another session, I can cover this, but the answer to the question is that it's similar testing Redux or React context in a similar way. The only thing you need to do is make your providers be something you can export, and then import them in your test and wrap your elements in the provider before you call render on them. Robin says, I do write end-to-end tests using Cypress, just started recently. I really like your presentation. I'm looking forward to part 2. Yeah, cool. I also will cover end-to-end testing sometime soon. The trophy I showed at the top is end-to-end testing. It's always a thin line between separating what needs to be unit tested, integration tested, and end-to-end tested, but all of them are important and they serve different specific purposes. For example, if you have an application that a user needs to drag something and drop it somewhere to upload a file, for example, you writing unit test for this will be not the best option. The best option will be to spin up a browser and simulate dragging the file and test that this upload got to be sent to the server, for example. And yeah, this works really nice with end-to-end testing. What I could say here, though, is that since a few months ago, I have switched. I stopped using Cypress because I found another alternative. It's called Playwright Test. And if I ever show end-to-end testing, I will be showing it with Playwright Test, but the concepts are totally the same. And I still have Cypress in some other projects, so it's also a really nice tool. It's just more heavy than Playwright Test. Yeah, Andrew, we're looking forward to the next session. Cool. Timothy, I haven't written test yet, like Steph. It is my first. It is in my to-do list. Quick question though. Can you also test on how performance and how performant your application is? Yes, but like this will be not directly a test as a test. You have to write your own performance metrics and then make assertions against this. So you'll look for a library, for example, that measures performance, and you would put it. So if you feel like a certain function is taking too much time, you'll put some counter before it and after it, and then get these numbers, and you can make assertions against these numbers and figure out what's happening. Yeah, but most of the time, you'll want to do stuff like this with something like page speed from Google. Yeah, I think instead of running tests, because normally whenever you run code, you also increase the performance burden on your application. So unless you are really careful, you will be testing the performance of your tests together with your application, which gives you wrong values. Yeah. And most of the time, most React apps are usually fast enough by default to need performance tests. I've never written a performance test before. Cool. So yeah, that was nice. I will try to see when I'm available again, and we can do some more stuff. If you have stuff you wish to see in the next presentation, you can get in touch through the Telegram group, and it was nice having all of you here. Yeah, Rama, can you take over?
Rama, okay, I think he might be held up. Held up. So I think that's a wrap for today. Thank you so much, Anthony. Thank you everyone who attended, and I think there's a recording. Yeah, Rama was doing a recording, so we'll also share with those who missed. And we're looking forward to having you for another session and more sessions. So yeah, so I guess that's it. In case anyone has any last words before we close. Okay. So I guess that's it. Have a good evening, everyone. Thank you so much, Anthony.
Cool. Thank you, and yeah, see you soon.
Bye.
Bye.